Hey guys, we are writing in index form again. So this is the second video, and just like the first video, we have a question there saying evaluate. We have different questions asking us to write in index form, but with certain parameters, such as not having negative or fractional indices. Okay, so we'll begin with the first question, and I'll just move these other two out of the way. Question 1a. Evaluate 8 to the power of 4 thirds. Okay, an evaluate question is a very open-ended question. It usually means the same as simplify. When we're answering this question, I need you to remember that we can deal with the powers, the numerator and the denominator section of the powers separately. Now guys, I'm going to deal with the denominator first because it just makes my job a lot easier. If I was to write this in a different way, I could write it as 8 to the power of a third, or to the power of 4. Now I hope we all remember that when we multiply indices, when we have indices with brackets, we can multiply them. 1/3 times 4 is 4/3, so there's nothing wrong there. I need you to remember again that 8 to the power of a third is the cubed root of 8, and that is still to the power of 4. And now, most of you guys who are working without a calculator like me will find this pretty easy to solve. The cubed root of 8 is 2. 2 to the power of 4 is 16. Okay, and now guys, if you type 8 to the power of 4 thirds, or 4/3, you should get 16 in your calculator. Question B. 125 to the power of negative 1/3. Okay, so now we're dealing with a negative indice that is also a fractional indice. Okay, so if I want to, I can deal with it this way. I can rewrite it as 125 to the power of negative 1 to the power of a third. So once again, if you were to multiply them, you'd still get the same answer of negative 1/3. I want to write the inverse of 125, and in doing so, I'll be able to get rid of that negative 1 power. So I have 125 to the power, when we have something to the power of a third, it's going to be the cubed root. So we have 1 over 125, and we can do it from separately. The cubed root of 1 is 1, the cubed root of 125 is 5, and that's your answer. Now obviously guys, that wasn't the easiest way to do it. There's a number of ways you can do it. Everyone has their own different way. Question C. Okay, so we have 2/3 to the power of negative 3. Alright, for this question I'm going to get rid of the negative indice first, and I'll tell you why. The negative indice seems to confuse a lot of people, and it's somewhere that people always seem to slip up on. They seem to make silly mistakes. Now remember that a negative indice means that we're going to be writing the inverse, and everyone knows that the inverse of 2/3 is 3/2. So I can write that power as 3 now, because I've gotten rid of that negative power. Or I want to break one of my golden rules, and I'm going to write 2 equal signs in the same line, just because I don't have enough space. But when we apply the cube to this fraction, we're going to apply it to top and bottom. So we're going to have 3 cubed over 2 cubed. 3 cubed is 27, 2 cubed is 8. And that will do for our answer. Okay, so moving on now. Gonna shove this over there, and we can begin dealing with question 2. Okay, so question 2a, we've been asked to write these things in index form. The square root of x to the power of 5. Now guys, if you want me to, I can rewrite question A like this. X to the power of 5, all to the power of a half. And that's what I'm going to write in place of a square root symbol. So remember that any root sign is an opportunity to write in index form. However, we haven't gotten the most simple answer. The most simple answer would be x to the power of 5/2. And of course we could have written this as x to the power of 2.5, however we generally don't write decimals in our indices. Okay, question B. And B is going to take up a fair bit of space. We have 1 over the cubed root of 4x squared minus 1 all squared. The first thing we're going to do is I'm going to get rid of these massive fractions. Now the inverse of all of this is just the denominator because it's over 1, or 1 is on top. And I write all of this to the power of -1. The next thing that I can write as a indice is the cubed root. So I'm going to be writing 4x squared minus 1 all squared, and that's going to be to the power of -1/3. Now I've got an indice out the side of that set of brackets, so straight away I can write 4x squared minus 1, and that's going to be to the power of -2/3. And I could factorise this question. It is what you call the difference of two squares. However, they haven't asked you to do it, so you don't need to. And that's question 2 done. Okie dokie. So I'll just move question 2 out of the way. And now I can get started on question 3. Right, to the power of -3/5 without the negative and fractional indices. Okay, so I want to do this first of all by writing it, well, you could do it a number of ways. An idea that some people prefer is to do this. Right, first the 3. Okay, how do you get -1/3/5? Oh, sorry, -3/5. You go 3 times it by a fifth, and then you times that by a -1. Okay, so how do we get rid of a negative indice? Well, we write the whole thing over 1. R cubed, power of 1/5. How do we get rid of fractional indices? Well, we write it as roots. So it's going to be the 5th root. So it's the 5th root of r to the power of 3. And there's an answer that has neither a fractional nor a negative indice.